In this step, I'm going to be preparing my cell lysate samples. So we're going to denature them in order to run them in the SDS PAGE gel. So for that, I basically use the Biorad 4X Laemmli sample buffer. So the first thing that we need to do when we look at the protocol, so very important that you have the protocol for the 4X and not the 2X. So you need to make sure that you have the appropriate Laemmli buffer. So for this, the first thing that I'm going to do is prepare it. So we're going to use 900 microliters of the 4X Laemmli buffer, and to that we're going to add 100 microliters of beta-mercaptan ethanol. So I already have my tube here, and I'm going to go ahead and prepare that. We have our 900. And to that, we're gonna go ahead and add the 100 microliters of beta-mercaptan ethanol. So I already have my pipette ready. If you're sensitive to the smell of beta-mercaptan ethanol, you can go ahead and do this in the chemistry hood. And that's it. Just invert it. And then we have our Laemmli ready to go that we're going to add to our samples. So let's go over the calculations of how I go ahead and prepare my samples, my cell lysates, in order to denature them. So in this case, I only have 2 samples. I'm working with mice retina cell lysates. On the first one, it's a retina that I resuspended in 50 microliters of RIPA buffer, and in my other sample I used 100 microliters. So I went ahead, did my dilution factors, I did my protein assay, I got my concentrations, my average, and this is actually microgram per microliter, not nanogram. So let me change that really quickly. And then I have my average. Since this is the same sample, I just did 3 different dilution factors. So I have my average. And so right now what I'm going to do is that I want to, for one of my samples, I'm going to prepare 50 micrograms. So that's the total amount of protein I want in my sample. And I want that sample to be in a total volume of 25 microliters, meaning that when I load into the SDS page, I am going to be loading 25 microliters. So the first thing that I do here is, you know, I want equal, if you're doing this in Excel, 50 micrograms divided by your concentration. So in this case, my concentration is 2.9, that's the average. And so it gives me a total volume of 17 microliters. Ahead, in order to get the amount of volume of sample that I need to have a total protein of 50 micrograms per sample. So I do equal, I put 50 divided by, and then what my sample concentration is, which is 2.99, and so that gives me 17 microliters. Once I know the amount of cell lysate sample, in this case tissue lysate sample. Then I want to make sure that I have a total amount of 25 microliters that I'm going to be loading. So to do that, remember that we're using also their sample. There's Vortex, Laemmli, and Ripa. For this one, you use 1/4 of your sample. So what I do is, once again, equal 25 5 divided by 4. It gives me 6.5 microliters. So 25 divided by 4, 6.5 microliters. One more time, I'm going to now explain my calculations for my second sample, in which I'm going to prepare 25 microliters that contain a total amount of 40 micrograms per protein. So in order to do that, we do equal 40 micrograms divided by our average concentration, which is right here, micrograms per microliter. So that comes to 10 microliters of our lysate sample will have 40 micrograms. So to this, once again, we want 25 microliters. So what I like doing with Excel, and I'm using the Vortex Laemmli. So to our sample, 1/4 should be Vortex Laemmli. So I go ahead and type 25 microliters divided by 4. And so 1/4 of that is 6. So let's put here 6. And then in order to determine what our Ripa buffer is going to be, we put equals 25 minus, and so it will be the summation of our sample plus our Vortex Laemmli. And so this should give us the total amount of Ripa buffer. So in order to verify that, you can go ahead, put equals to, if you're doing this in Excel, sum, and you're going to get this right here. So you add those 3 values. Okay. Okay, there we go. So after we've done our calculations, we're going to go ahead and prepare our cell lysates. So I know that I have here enough to do 2 runs or 2 loads of in my SDS PAGE gel. So I have, in 10 microliters of sample, I have 40 micrograms of protein. So to that, I'm going to add, since I'm doing 2 reactions here, 12.5 microliters of the Laemmli. So 12.5, and that's going to go in here. And then to make sure that our total volume is 25 microliters per reaction, now we're going to fill the rest with our Ripa buffer, which is the same lysine buffer that you use to lyse your samples. For that, we're using 18 microliters. Okay, so here I'm going to prepare my second sample. And so I already did my calculations, which I showed you. And so all I have to do now is add my Vortex Laemmli that has the beta-mercaptoethanol and the Ripa buffer to bring it to the desired volume of 25 microliters per sample per well. So for Laemmli, I'm going to add, for my case, 23 microliters. So mix it. Okay, I have my 23 microliters. Then go ahead and add it. Mix it. And now my rip-up buffer. And for rip-up buffer, I'm only using 7 microliters. So I have my rip-up. Mix it. Vortex quickly, and after vortexing them, briefly spin them down. Now we can go ahead and denature our samples for 5 minutes. Okay, put your sample here, 5 minutes, and we have it at 90.